And
Okay.
this is a really vital. You got to be able to solve equations. You can't go anywhere in math if you can't solve equations. Okay, so we're going to start real simple.
Yeah, I think my barn. That's all.
Hold on a second. My drawing tablet was cleaning. It looks like it. I'm going to have to unplug it and plug it back in. And now let's see if it works. Ah, good.
So, Mom, are you gonna go anywhere, guys?
Can you solve that for x?
1, 5. Wouldn't it be 2?
What is it? I can't hear.
2?
Yeah. So, okay, we'll make it a little bit more complicated. Solve that for x.
7.
Solve that for x. Here's the thing with equations, Jackson. You can do anything you want to one side of the equation as long as you do it to the other side.
Yeah.
What you're always trying to do is the opposite. In other words, we're always trying to get x equals something. So the secret is to get rid of everything that is not x. Well, the only thing on the left side that's not x is the 4. What is the 4 currently doing?
The 4 is currently dividing.
Dividing. So you always need to do the opposite. So what do we have to do to get rid of the 4? What's the opposite of division?
Multiplication.
Correct. So we got to multiply by 4. We do the left by 4, we got to do the right by 4.
That's 40.
Right. Now notice we can cross those 4s off.
And it equals 10.
X equal 40. Make it a little more complicated.
Divided by minus things is equals to 1.
Here we've got a combination of things. We still only have one x, and everything else is numbers.
Don't we subtract? Don't we plus 4 to 1? That was 6. I mean,
The sequence that you do these is vital.
Yeah.
The first thing that you can easily get rid of is what? What's the easiest thing to get rid of on the left side of the equation?
Wait, what'd you say? Sorry.
What's the easiest first thing to get rid of? That's what we're trying to do. So we're trying to get rid of the 3, the 5, the 4, and the -6.
The 5.
No, that's not the first thing.
Oh, no, the -6. The -6.
Because I can get rid of this without affecting any of that.
Don't you just plus?
I can't get rid of the 5 unless I want to multiply that -6 by 5 also. So I'm going to add 6 to both sides.
And then that equals 7.
Okay, now always just do these one step at a time and write your second step. Right? That's what we get when we do that first operation.
Don't you multiply 5 times on both sides now?
Yes, that is the next best correct thing to do. Notice we can't really subtract 4 yet because 4 is being divided by that 5 also. So we're going to multiply both sides by 5.
So we multiply 4 2 by 5 2.
No, don't have to, because this 5 cancels that 5. We don't have to distribute that 5. Normally you would. We'll do some problems like
So
that.
equals,
That's coming.
it
But
just equals x plus 4 equals 35.
now what?
Let me just. No. How do I shut my. Oh, never mind. I got it. No. I don't know. I don't know.
What's the next step in solving this equation?
You.
There's two things you got to get rid of, right? What are they?
4. You subtract 4 from
Exactly.
30.
Get rid of that one first. So now we got 3x equals 31. And what's the last step?
We have to divide, but.
Okay, so we end up with 31 divided by 3. There is the answer.
Yeah.
So solving equations is just doing one thing at a time, but you got to know which thing to do first. Okay. This thing we had to get rid of the 3, we had to get rid of the 4, we had to get rid of the 5, and we had to get rid of the 6. And the order that you do it makes it easier. You could do it in any order you want it. I could have actually multiplied my first step, multiplied both sides by 5. It's what it does is it makes the numbers bigger than they necessarily would have to be.
Yeah.
All right? So you don't want to do that. So the sequence you go about solving these equations is important. Okay, now I'm going to add another wrinkle in it. Okay, now we got x on both sides of the equation.
Well, you have to add like terms. So
Okay.
you add plus 3 to -7, which equals -4.
Hold on. Always you got to do the opposite of what that 3 is doing. What is that 3 currently doing?
Oh, negative.
Okay. So I got to do -3 to both sides. What's the next line? Tell me what the next line is.
3x equals
Hold on.
10.
Let's do one step at a time. What's that?
It's 10.
Let's sign first.
-10.
Notice that if I just write 10, that has no meaning. That actually means 10 times x.
Oh, equals.
So I have to have a sign there, whether it's plus or minus. I need a sign. Okay? Now, what's the next step? Because all we did was consolidate the numbers. We got all the numbers on the right side of the equation. Now we got to get all the x's onto the left side of the equation.
Mm-hmm.
How do I get that x that over here that's on the right over to the left side?
Well, you divide, if I'm not correct.
How can I get it?
You combine like terms. Sorry, you combine like terms, so it's 3x.
No, you don't combine like terms. That's really a misnomer. In other words, combining like terms would give you 3x. But we're not really combining like terms. What I'm doing is I'm subtracting x from both sides. Right?
Oh, yeah.
X is currently being added to that -10. I know it says x minus 10, but in reality, that x is being added. So, to get rid of it, I got to subtract it. Okay?
Yeah.
Now, what's the left side equal to?
1x.
Just x. We don't write the 1 if we don't need to. What's the right side equal to?
-10.
There you go. Okay? All right. Tell me how we're going to proceed here. It's a little more complicated than the previous problem. We still have x's on both sides, numbers on both sides. You're right. We want to combine like terms, but what combine like terms really means is it means putting all of your x terms on one side and all of your numbers on the other. That's what it means.
Okay.
If you have two variables, then you combine all your x terms, you combine all your y terms, and you put all your numbers on the other side. But combining like terms basically means separating your variable terms from your numbers. So, give me a first step. And when I'm thinking first steps, remember PEMDAS?
No, yeah.
This is the order of operations. The P stands for parentheses. The E stands for exponents. The M stands for multiplication, division, addition, subtraction. So I'm going to erase that because that doesn't necessarily apply when we're solving equations. That's what you use when somebody has written an expression incorrectly to figure out how to solve it. But the key is, when I look at an equation, I want to get rid of my parentheses and I want to get rid of all my denominators. Do we have any denominators here?
No.
Do we have any parentheses?
Yeah.
Give me a second line that gets rid of that parentheses. One step at a time.
4x minus 7 equals 3x plus 15.
That's not all.
Minus negative 6.
Just minus 6. It's not minus a negative 6. It's actually minus a positive 6. That's what that means. Or you could say it's adding a negative 6, but it's not minus a negative 6. If it were minus a negative 6, then it would be plus 6. So you got to keep your signs straight. You got to pay a lot of attention to your signs. You get the signs wrong, you'll never get the math right. Next step.
You should try. Get rid of negative 7.
Well, how about we just do this one step at a time? We can certainly do that, can't we? Let's do it. One step at a time. What's that plus 15 minus 6 equal to?
9.
Plus 9. Got to have the plus sign there because it's part of an expression. It's not all on its own where you could leave the plus sign off. It's part of this expression, 3x plus 9. Okay, next step.
You subtract 3x.
Okay. From both sides. Always make sure you say that. What does that give you?
1x.
Just x. Don't say the 1. It's not needed. What else on the left? We haven't done anything to that 7 yet. We did get rid of those two. So now you can leave the plus sign off the 9. Because all we're looking at is a number. If there's only a number there, you don't need the sign on it. And finally, what's the last step?
To subtract negative 7 from 9.
Oh, I don't like the way you're saying that. You're not subtracting negative 7. What is the 7 currently doing?
Subtracting.
Right. So what do you have to do to get rid of it? The opposite.
Divide.
Add. Opposite of subtraction is addition. The opposite of multiplication is division. So addition and subtraction go together as opposites, and multiplication and division go together as opposites. Okay, so what's the last answer here?
Negative.
No.
Wait.
What are you doing?
No.
You're adding 7 to both sides. If you have to look at it like this, do this.
X equals 16.
Okay. That's the way you solve an equation. Now, I'm going to change it slightly, just because I want you to know that you don't always have your X on the left side. Sometimes you can put it on the right side. And sometimes that's the easier thing to do. I'll show you a case. We'll make this a little bit easier. I'll take away that -6. Now, what's the first step in solving this one?
Parentheses.
Okay, so I'm not going to do anything to this side yet. Distribute that 4. That gets rid of the parentheses.
Yes.
What is it?
Oh, 4x plus 20.
Okay. Now, you always get to a point in solving an equation when you have variables on both sides as to which side you want your variable to end up on. Because I have a choice. I can move my x's to the right and my numbers to the left, or I can move my x's to the left and my numbers to the right. In this problem, which would make more sense? And why?
Well, you should.
If I move my x's to the left, what's my sign going to be on the x? It's going to be plus or minus?
Minus.
That's not a good thing. Stay away from negative signs if you can. If I move my x's to the right side of the equation, what's the sign going to be on the coefficient of x?
Positive.
Yeah. So let's begin this problem by subtracting 3x from both sides. Well, what's that leave on the left side?
Oh shoot, what is it?
We got 3x minus 7 minus 3x.
Well, 3x, that's 1, that's x.
What's 3x minus 3x?
0.
Okay, so what's left on that left side?
-7 equals x plus 20.
Equals x plus what?
20.
Okay. Now we've got the x on the right side. It's got a 1 as a coefficient. It's positive. All the things we're looking for. So the last step is to what?
To add -7 to 20.
No, that puts everything on the right side. What I'm trying to do is separate the variables from the numbers. I already got the variable over here on the right. I'm going to leave it there because it's perfect where it's at. So what do I got to get rid of? Here's what I want my final answer to read. Something over there, a number. So what have I got to get rid of? What does the x currently have on the same side of its equation that I got to get rid of?
Oh, I'm so confused.
Read this line, Jackson. Can you see that line? You can't read that line?
No, -7
Equals what?
equals x.
No, that's not what it says. I'm not sure whether you're seeing my whole screen or not. Read that line. Bottom line you see.
-7 equals x plus 20.
Well, how come you were leaving off the plus 20 before?
I don't know.
So what do we got to get rid of if we're trying to end up with x only?
You gotta get rid of 20.
The plus 20. So what do I have to do? How do I get rid of that 20? In other words, I got to get this 20 to the other side. That's what I'm trying to get into your head is that you don't have to have variables on the left, numbers on the right. You can have variables on the right, numbers on the left. It's just as good. Sometimes it's a much better way to do a problem. So how do I get rid of that plus 20? What's it currently doing? Is it adding, subtracting, multiplying, or dividing?
You subtract it.
Okay. So subtract 20 from both sides.
And that equals -27.
Okay. That's your answer. And that is the best way to do it. Now, if I did it the other way, I could. I don't have to put everything on the right side of the equation. I could bring the 4x. In other words, let's do it the way we kind of did the first one. I'm going to subtract 4x from both sides. Okay, what's the next line?
1x, -1x.
Negative x. Don't say the 1 if you don't have to. As long as that 1 is a coefficient, don't say it. If it's standing out by itself, like +1 or -1, then you got to say it. But if it's multiplying something, like a variable, like x, you don't say it. Okay? So what's the whole line now? Minus x what?
Minus x -7 equals 20.
Okay. What's the next line?
Negatives. You're adding negative x equals 27.
Equals what? 20 or 27?
27.
Okay. Now, we're trying to solve for x. We're not trying to solve for negative x. So what's the last step I got to do here?
You gotta divide
By?
x.
No.
Negative x.
No. -1. Dividing by a negative. When you have a negative divided by a negative, what do you get?
Positive.
Okay. So that leaves x all on its own on the left side. And now 27 divided by -1 is what?
27.
Nope. It's 27 divided by -1.
-27.
Okay. There's your answer. Notice that it's the same answer we got doing it the other way, where we had the x on the right side. But it also required this one last additional step where I had to divide both sides by -1. Whereas when we did it the other way, it's one step faster, one step more efficient.
Yeah.
Okay. All right. We got about 4 minutes here. I want to see how you're doing on flashcards. As you can see, when we solve equations, you have to do about 6 flashcards worth of math per equation, right?
Yeah.
I mean, all you were doing was subtracting 7, adding 7, multiplying by 3, dividing by 6. That's all you do when you solve equations. Once you learn how to solve an equation, which steps to actually do, the only thing left is all of that arithmetic. And that's why I'm spending so much time doing this. It's because this is what you have to do all day long when you're solving equations. Go ahead.
Oh, -4.
You need to be faster at this. It's not going to work to be this slow. You can't take 15 seconds to solve every one of these math problems, these arithmetic problems. Okay? So I want you to work on your speed. When you're practicing it on your own, try to go as fast as you can. If you get it wrong, you get it wrong and back up and redo it. But I want you to consider speed. You can't take 15 seconds. There's 6 of these things to do per equation.
Yeah.
What's this?
That's positive 8.
Okay. No, that's not correct. What kind of a problem is this? This is a subtraction problem involving another negative number, correct?
Yeah.
These are all two-step problems. I don't want you to try to do it in one step. I want you to have a pencil and paper in front of you, if you have to, and do this in the following way. First, change it to an addition problem. And because I did that, I have to change the sign on what was being subtracted. So now I have 11 plus a plus 3. What is that?
14.
Okay, that's the way you need to do them. And you need to get in the habit of doing them. And you need to do them as 2 steps. Because when you try to do it at 1 step, it takes you too long. I don't care if it takes 5 seconds to do each step. Do it in 2 steps. You'll do it faster. Okay? Again, we have a subtraction problem involving a lot of negative signs. So what am I going to do? How many steps is this?
It's 2.
Okay, what's the first step? You tell me.
You make it plus addition problem. So it's -10 plus positive 3.
Good. Now,
Negative.
I'll write that out just so I can get rid of the parentheses and I can get rid of one of these plus signs. Whenever you have 2 plus signs together, just get rid of one of them. So that problem, after you did that first step, you get this. Now you got to do the second step. What's -10 plus 3?
It's -7.
Okay. With that, I will let you go.
All right, bye.
All right, we made good progress today. It may not feel like it, but we made a lot better progress today than we have in the past. You got to know how to do arithmetic, and you got to know how to do algebra equations.
Okay.
Okay? All right.
Good.
Jackson, I'll talk to you next time. Bye-bye.